Once again welcome back. So, now we are starting this video from question number 87. This topic, that is you can say radioactivity, is one of the important topic, important in the sense it is here in your modern physics and also in your chemistry, fine. So, it is like that you prepare one topic and there is a very good probability that you may get question from both these subjects. So, let us take a look of this particular question, although a simple question, but sometimes in radioactivity problems there is a possibility that some calculations may be long. So, you just have to take care of that aspect. The half life of radium is 1600 years, fine. What is the fraction of sample undecayed after 6400 years? Well, there are two formulae to solve this. So, I think the best possible simplest method is fine. Now, after how much time? Years. So, how many half lives over here? So, you can say n is equal to T upon T half. So, it will give me what? 6400 upon 1600. So, n is equal to 4, fine. Although I need not to write down this, directly you can say 4 half lives. Problem is do not practice for shortcuts like this, otherwise it may possible that in some questions you may commit some blunders. So, please, while practicing in home or school you should follow this method, but in examination hall once you are comfortable then quickly you can do that. Now, for this after what I should write down, a well known relation. Now, from here how much you can say fraction of sample undecayed? So, it is 1 by 2, 4. So, answer is fine. So, correct option is option number A, that is 1 by 16. Well, there is a possibility, fine, that a student may start this problem by using a method like n is equal to n naught e to the power minus lambda t. So, I will suggest that do not try to follow a long path, long way, fine. Lamba rasta, please do not try to follow, because there after this you know what you will have to do. Given, can find out from here n upon n naught log and so on so forth. There is no point of taking this route. When shortcut is given, I think we can follow that. Fine. After this, question number 88. When a slow neutron is captured by 92U235, basically it is nuclear fission reaction, and slow moving neutrons are required for the process of nuclear fission to start, to initiate. You know what will happen? 92U235, right now I am not talking about the question, I am just telling you the process. It will give me, it is unstable. So, it will break in krypton and barium, fine, Kr and barium, and after that 3 neutrons also. So, this is basically nuclear fission reaction. Anyway, let us take a look of what exactly the problem is asking. Fine, a fission energy releasing 200 MeV. Actually, students, you should remember this. Nuclear fusion, it gives us clean fuel, clean energy. It each fusion provides us around 24 MeV, million electron volt, while each fission gives us 200 million electron volts. So, you can say output of fission is roughly 8 times more but this is not a, you can say, a environmental friendly this reaction, fine. Because nuclear waste and then you can say arranging the nuclear waste is a big problem. You have to put this nuclear waste in lead drums, and you have to put these nuclear waste containing lead drums in deep sea, because simply you cannot throw it anywhere. So, if power of nuclear reactor is 100 watt, the rate of nuclear fission is how it is moving, or how many fission reactions per second taking place per second, 10 to the power 6 per second, 12 per second, 4 and so on. 200 million electron volts. So, it is 200 into 1 into 10 to the power 6, okay, correct, 1.6 into 10 to the power minus 19, fine, it will give me in joule. So, it is 128, it is 3.2 into 10 to the power 11 joule, fine. So, each fission is providing me into, this is the amount of energy that I am getting after each fission. After that, rate of fission is equal to power upon energy of each fission, energy of each fission. Okay. So, power is 100 watt and 3.2 into 10 to the power 11 minus 11, fine. So, when I solve it, I will get it as 100 upon 32, okay, into 10 to the power 11. So, 1, 2, 3 and then it should be divided by added over here. Ultimately, after solving, I will get the resultant as 3.1 into 10 to the power 12, because when I divide 1 by 32, so also I will get some numbers with decimal places. So, we have to replace those decimal places. So, 3.1 into 10 to the power 12 is the correct answer. So, B is your correct option, fine. So, these questions are very simple, but yes, up to some extent they will engage you for calculation, fine. So, slight amount of practice of these calculations will definitely help you out to score more marks. After that, question number, it is in the segment of reason assertion. So, first question is 89, I mean, gamma radiation emission may occurs after alpha and beta decay. It is correct, and how it is correct I am going to tell you, but this statement is correct. Energy levels occurs in nucleus, fine. Now, energy level occurs in nucleus, that you know, first allowed state, second allowed state and so on. So, this is also clear, it is true. How gamma radiation emission takes place? Actually, alpha beta emission takes place because a nucleus wants to reduce its size, fine, and this gamma is not a particle, it is a energy. So, this energy radiation takes place because during any nuclear reaction, energy, linear momentum, angular momentum, parity, baryon number, charge, lepton number and so on so forth. So many things must remain conserved. These are fundamental laws. So, this gamma radiation emission alpha after alpha or beta may take place, it is true, it is also true. So, I think this also explains this first statement, because you know when electron jumps from second to third, fourth to second, so it emits energy in the form of gamma radiation. So, I think the correct option is A, that is both are true, and this statement is also explaining the, you can say, this first statement. Fine. Question number 90. Size of nucleus is constant in electron scattering or gamma scattering. So, obviously, nucleus size is something which is considered as collection of nucleons within nucleus, that is protons and neutrons. Fine. So, during electron scattering or gamma scattering means nucleus is fixed and electron is it comes to strike it and it moves. So, actually it is not breaking it, fine. So, its size remains constant. So, this statement is true, that is alpha particle scattering Rutherford's experiment, nothing happens with the size of the nucleus. Electron scattering or gamma scattering is controlled by distribution of charge in nucleus. Well, electron scattering or gamma scattering is controlled by distribution of charge in nucleus is not so correct. Reason is, nucleus is confined, fine, and it is like that protons and neutrons are arranged in such a manner charge is balanced basically, and outside of the nucleons electrons are revolving in a cloud. So, all in all this entire entity is balanced. So, this statement is not true, but this one is true. So, simply you can say that in this particular question number 90, your option C is correct, that is first statement is true and this statement is not true. Fine. Question number 91. Now, it is based from your this idea of what, that is semiconducting material devices. Now, semiconducting material devices and question based upon that, they are important because communication and semiconductors, around 2 to 3 questions there is a very good probability. If you just pick paper of AIIMS previous year question papers from exams, you will definitely find 2 to 3 questions minimum are there. So, we can't ignore it, we can't afford to ignore it. A zener diode is specified as having a breakdown voltage of 9.1 volt with a maximum power dissipation of 364 milliwatt 10 to the power minus 3 watt. What is the maximum current the diode can handle? Okay. We have a relation class 10th onwards, fine. So, power is given and accordingly this voltage is given. So, we can use this value, that is 364 minus 3 is equal to 1 into I. I hope it is so simple for you to understand it. Now, I is equal to upon 9.1. Let us start solving. So, for solution I can assume that it is 90, let us say, fine, 9.0, and then if you solve, so roughly you will get it as 40 into 10 to the power minus 3. Yes, fine, roughly. So, it is going to be how much? 40 milliampere, fine. So, 40 milliampere, that is A is the correct option for this particular question. Next question 92. a transistor connected at common emitter means beta mode contains load resistance 5 kilo ohm. Okay. If the input peak voltage is 5 millivolt, fine. Okay. And the current gain beta is 50, find the voltage gain. Voltage gain, okay. Current gain is this much, so find the voltage gain, fine. R output is given, V input is given, fine, 5 millivolt. And the current gain beta is given, we have to find the voltage gain. One into 10 to the power 3 ohm, fine, it is input, fine. Now AV is equal to beta, sorry, RO upon Rin, fine, RO upon Rin. So from here if I put the values, so 50 into how much it is? 5, that is 250, fine. So find the voltage gain, simple, voltage gain is 250, that is A is the correct option. And these basic formulae are simple to remember, and there is no point of ignoring these simple results, fine. Question number 93. The output for the given circuit is how? You can define it. Actually, in your course there is one topic mentioned, a small topic, Boolean expressions, Boolean algebra. So this question is based upon that particular Boolean expression. But say for example, you are unable to understand any of this particular situation, but you can recognize the gate at least. This is your OR gate, NOT gate, AND gate, fine. So for OR gate, what I will write down? A plus B, fine. And for AND gate, what I will write down now? But before that, there is one NOT gate present in this situation. So this particular scenario is A plus B. It is true for what? It is true for this situation. But whatever the B input it will get as, because of this NOT gate. So now over here, fine, and for AND gate, A dot B type of result is true. I think you will get confused. For AND gate, X dot Y is true. So X is what? Y is this. So the result you will get, fine. Now compare it. Okay, simple logic based question, simple Boolean expression. Question number 94. Now the same type of question, same type in the sense same approach of the question, but I will tell you a different mode of how you can solve it. Okay. So here there are two methods. Either you use your Boolean expression form and then you can say it is what? It is your NOR gate. See, NOR gate input, and it is not and then NOT gate. So either you can use your Boolean expression or you can use what? Truth table approach. So, Boolean expression I explained you in the previous problem. Now, for this particular question, consider the Boolean expression, this truth table approach. A, B, C, D, E. Yes, A, B, C, D, E. Fine. 1, 2, 3, 4, 5. Yes. Few of you may think, sir, this is a long approach, but it is a simple. Fine. It will take around 1 minute time, but problem is it is quite simple. Let us start putting the values. Okay. 0. 0, 0, 1, 1. Why I am taking 0, 0, 1, 1? You can take 1, 1, 0, 0. You can take 0, 1, 0. I mean, only possibilities are what? Only possibilities are high or low, true or false, 0 or 1. So, I am considering all these options for the first gate. So, if it is 0, it is going to give me 0 over here, and then again over here it is 1, 0 and 1. Fine. Output of this, because these are possibilities, low, 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 high, high, low, high, high. These are the possibilities possible over here. So, I mentioned. Now, C is this. So, C what I will get, low, low, resultant is high, but negation will give me low, 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 sorry, high. It should be high. Yes. After that, low, high will give me high, but negation will give me low. High, low will give me high, but negation will give me this. And after this, high, 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 but negation will give me low. Fine. Now, reverse of it possibility is 0, because this is negation sign. It is 1, 1, 1, and outcome of it 1, 0, 0, 0. Fine. So, the correct option is it is a NOR gate. So, you can use this truth table approach, or you can use Boolean expression approach, that is Y1. So, say for example, for Y1, it is Y2. So, for Y2 what I will write down, A plus B bar bar, that is A dot B, and again it will give me A, this is Y3. So, you can use either this approach or this approach. A is your correct option, or this truth table approach. Choice is yours. And these are simple questions. Some amount of practice will definitely makes you comfortable with these questions. Question number 95, oh, it's again reason assertion. Fine. So, same options. First question, in zener diode depletion layer is thin. Well, this is directly picked from your this textbook. Fine. So, if you are reading the, you can say, chapter, you should try to understand this particular idea of thickness of depletion region, forbidden energy gap, and all these things. This fact is true, zener diode depletion layer is thin because it works in reverse biasing. In reverse bias, strong electric field exists across the potential barrier. So, both are simple facts, both are true, but it is not like that reason is explaining this assertion. So, in my opinion, the correct option is B. Fine, both are true, but not correct explanation. In solar cell, it is imperative means I mentioned essential, that photogeneration of electrons and holes occurs in depletion region. It is also a fact. And solar cell, light emitting diode, zener diode, photo cell, they all are the part of your course curricula. The junction field separates electron holes pairs effectively because both have different charge. So, both these statements are true, but it is also explaining this one. So, the correct option for 96 is A. Okay. In amplitude modulated waves, it is communication system. One question minimum is possible, minimum one question. In amplitude modulated waves, maximum amplitude is 30 MeV and minimum is 5. Then find out the modulating index. Modulating index M is equal to V max upon V min upon V max plus V min. Okay. So, let us put the values 30 minus 5 upon 30 plus 5, 25 upon 35 0.7, fine. 0.7 is correct answer, that is C. This is the formula modulation index is equal to this much. After that, question number 98, again reason assertion. First question, sky wave signals are used for long distance radio communication because it is like that from ionosphere they gets reflected, fine. These signals are in general less stable than ground wave signals, less stable, fine, but they can travel large distances. So, this statement is true. State of ionosphere varies from hour to hour, day to day and season to season. In the morning something else, as the sunlight starts coming out it is different. So, this is true, but it is not explaining it, fine. So, I think the correct option is B, both statements are true, and this is directly picked from your this chapter communication. In a communication system based on amplitude modulation, frequency modulation and amplitude modulation, there are two type of modulation are mentioned, and my suggestion is at least you should devote around 15 to 20 minutes time to read these. Amplitude modulation, the modulation index is kept less than unity, and the modulation index, just 1 minute back I calculated, M is equal to V max minus V min upon V max plus V min, fine. So, that was also less than, so it kept less than 1. It ensures minimum distortion of the signal. So, this is properly, both are correct, and it is also explaining that why it is always reduced or less than unity, so that it can ensure that some sort of noise and distortion signals are not present. Then comes question number 100. In the transmission of long distance radio signals, short wave band is used. It is true, fact. I do not know right now you people are using it or not. Nowadays people are not using, only using FM radios, but in olden days in villages people used to listen a transistor, a big device, and there were two modes, medium wave and short wave. So, short wave is something that is used over here and the energy is more, fine. So, they travel more distances. In the shorter wavelength, attenuation is very less. Wavelength is short, energy is more, so attenuation is less. So, this is also, both are true, and it is also explaining this first one, fine. So, with this we are finishing this crash course. Hope you will revise these 100 questions, not for sake of that you will get these questions, but at least it will give you some idea how you should move, fine. So, saying thanks to all of you for watching these videos. Take care of yourself, best of luck for your exams.